Welcome back, folks. This is Jack again with part 2 of the pattern detector video presentation. Now, we finished off previously the Mealy FSM pattern detector design for 100, and this is as far as we got. I'm just going to quickly press the buttons, and hopefully everyone's okay with this. Clearly, there's 3 states, and therefore we need 2 state variables to actually design the system that will implement this kind of function. Now, the state table is derived in exactly the same way as the more state table is derived, and it kind of describes the same information but in tabular form rather than graphical form. I hope everyone can understand this state table and relate it to the finite state machine. We'll move now on to a slightly more complex example. These are the kind of examples that we did quite a lot in the class and tutorials. A synchronous pattern detector system is required which has a serial bit, an external input X and an external input F. The output should only be at logic level 1 for the last bit of the following 2 binary patterns. Those patterns are 1001 or 010. Once a pattern is complete, the next bit should become the first bit of another pattern, i.e. no overlapping. Now, in most of the examples that we covered in the lecture tutorial, I did kind of specify that overlapping is permissible. But in this particular example, for this particular example, overlapping is not permissible. Now, let me just clearly define what I mean by overlapping. Now, if X had actually equaled 1001, 0, then clearly, by the way, I'm working from left to right. Clearly, there's a pattern there, 1001, so F should be 1 there. Also, we could kind of count the last 2 bits of the first pattern as the first 2 bits of the second pattern, i.e. this. Can you see that? Hopefully you can see that. Then F will be 1 there as well. That's what I mean by overlapping. For this system, however, there is non-overlapping permissible. So this is what I mean. So where we are, that's where we are. No overlapping means no, no, no. But that is the first bit of the new pattern. Now, the next few slides we'll actually design the state machine for this system. We'll do it using a Moore machine and a Mealy machine, and then determine the state tables from that. Okay, so the Mealy finite state machine is as follows. State 0 is start up and reset. If the input is 0, output of course is 0. Then state 1, and we back that 0. If the input is 1, state 2, and we back that 1. In state 1, if the input is 0, stay in state 1. If the input is 1, move over to state 3. We've backed 2 bits there, 0, 1. In state 2, if the input is 1, stay in state 2. If the input is 0, go to state 4. 1, 0 there. State 3, if the input is 0, we've actually hit the pattern 0, 1, 0, and we can move over to reset the system. If the input in state 3 is 1, we move to state 2, where there's a 1 anyway. In state 4, if the input is 1, move to state 3. In state 4, if the input is 0, move to another state, state 5. State 5 is 1, 0, 0. In state 5, if input is 0, go to state 1. If input is 1, go to state 0, and you've got output 1 as well. I hope that's okay. I mean, go through it a couple of times, by all means, and hopefully it should make sense. I must kind of stress that this is not the only solution, that you might well think of another solution which uses less states or maybe more states. It doesn't really matter as long as it works. That's all I'm concerned with. Okay, the system uses 6 states, therefore 3 state variables are required. Now, the Moore finite state machine. That is as follows. I'm just going to keep clicking rather than saying it. Very, very similar. It's just that we're using more states for the more because the system cannot change state within it's change an output within a state. Okay. Okay, I hope everyone's okay with that one. Now that's my more finite state machine. I have actually got another version of a more state machine which is slightly more efficient in as that it doesn't have two states as output, it only has one state as an output. I'll show you what I mean. By the way, this state machine uses 8 states, therefore we need 3 state variables. Can you see now in state 6, when the next input is 1, i.e. 1001, well then the output is 1. But instead of making it in brand new state 7 previously, now it goes into state 5. This is the state that was initially high in the first place. So it's slightly more efficient this way. But I mean, if you find this confusing at all, the previous 2.0 more finite state machine would be fine as well. This is just missed off, kind of reduced it by 1 state, but 3 state variables still required. Now I have here these relevant state assignment table or state tables for the Mealy this is. And because there's 3 state variables, that means there's actually 8 unique sequences, 8 states. But each of those 8 states has to be written twice because we've got to exhaust all possibilities that X can take. It can only take 0 or 1. Not all of the states are used for this Mealy machine. For example, state 6 and state 7 aren't used. Now you'll see the next state, A plus B plus C plus R, the next state, A, B, C are the present state. The next states for the states that haven't been used is don't care. We don't care if they're 0 or 1. However, we do care about the output. Always keep the output as 0. Always keep the output as 0. Just in case, that is. Just in case there's a glitch in the system which kind of takes it into that state. If you put it as don't care, well that could go to 1. So fix the output as 0, but leave the next states at don't care. This is the more. This is the more finite state table. This is actually 2.0, sorry. It should be 2.1. And kind of relate this to the state machine that I've got. This is 2.0 by the way, not 2.1. And this is 2.1. Okay, and I know it's brief, but I think my 10 minutes are approaching rapidly, so I've got to say goodbye for this session actually. If there are any questions, please kind of email me for BCU students, but for non-BCU students and actually BCU students, you can just leave a comment on YouTube and I will get back to you as soon as I possibly can. Thank you very much for listening. Bye bye.